or ray that intersects a circle at 2 points. Just stop right there. A secant is a line, ray, or segment that intersects a circle at 2 points. So a secant is a line, ray, or segment that intersects a circle at 2 points. So AC here is a secant because it hits it there and there. BD is a secant because it hits it there and there. So angle 1 here equals this arc here plus this arc here divided by 2. It's the average of the two arcs. Okay? So angle 1 equals half of this arc plus half of this arc. Or let's say this is 80 and this is 120. What's 80 plus 120? 200. Half of 200 is 100. So angle 1 would be 100. Easy peasy lemon squeezy, right? So if two secants cross inside the circle, we add up the two arcs they cut off and divide it by 2. Okay? So that's what this first one means. That's what this one means. So angle 1's right here. You take this plus this and take a half of it, and that's what the angle is. Okay? That's what the angle is. That part's easy. We'll get harder. But this part is easy. All right. So, when we form an angle on the inside of the circle, we add up this and take 1/2 of it. That's what we just said. When the angle's on the outside of the circle, we take the big minus the little. We subtract this time. We don't add. See how the angles on the inside, we add. The angles on the outside, we subtract. So we take this minus this and take 1/2 of that. So we're going to subtract. Here, the angles on the outside, we take the big minus the little, whatever that is, take 1/2 of that. Okay? Angle 3 is on the outside, so we take the big minus the little and we take 1/2 of that. Okay? So now we're going to start doing them with numbers in them. Okay, how many degrees are in a circle? 360. If there's 151 there, 139 there, what's left for that? $151 and 139 add up to 290. So how much is left for AC? 70. So to figure out angle B, it equals 1/2 of the big part, 151, minus the little part, 70. It has nothing to do with 139. 139 is on the outside of that angle. It's what's on the inside of the angle that counts. So it's 1/2 of 81. What's 1/2 of 81? Well, it's 40.5. Okay? Angle on the outside of the circle. Okay. Angle on the outside of the circle. 34 is the angle on the outside of the circle. It equals 1/2 of the big part, 6x plus 6, minus the little part, 3x minus 5. Well, we got to be careful here. We got to put this in parentheses and this in parentheses. When I have a minus in front of parentheses, I need to do what to it? Distribute the minus sign. So it becomes plus, a negative, and a positive. So 34 equals 1/2 of 6x minus 3x is 3x. 6 plus 5 is plus 11. Now, I'm going to get a whole bunch of fractions if I distribute my 1/2 through there, right? And you guys don't like fractions that much. So we don't have to work with fractions. What should I multiply by to get rid of this 1/2? What would I multiply by to get rid of that 1/2? 2. Multiply by its reciprocal. Multiply by 2. So 68 equals 3x minus or plus 11. So if we subtract 11 now, we get 57 equals 3x divided by 3. X equals 19. Whoops. X equals 19. Okay? So when the angle's on the outside of the circle, you take 1/2 of the big part minus the little part. When the angle's on the inside of the circle, and we want to find WX here, so let's just put A here. We want to find A. The angle, like angle 1, equals 1/2 of the two arcs, ZY and XW, added together. Correct? Because when the angle's on the inside, we add. So 107 equals 1/2 of 74 plus A. Again, I want to solve for this. I got a 1/2. I don't want to mess with fractions, so what do I multiply both sides by? 2. We multiply by 2, that gets rid of that. Multiply by 2. I get 214 equals 74 plus A. How do I get A alone? Minus 74. So 140 equals A. So this is 140 degrees. Looks like my angle's on the outside of the circle. Angle S is on the outside. So am I going to add or subtract? Subtract. Now this is 152, this is 126. What's left for PR? What's left? 82. 82 is that left. So angle S equals 1/2 of the big part, 152, minus the little part, 82. This has nothing to do with it because it's on the outside of the angle. So 1/2 of 70, which is 35. It's a 35-degree angle. Okay, angles. We should be good with angles now, right? Okay. JK is, 69. KL is 44. LM is 163. What's angle Z? Well, what's left for JM? How many degrees in a circle? 360. So 360 minus 163 minus 44 minus 69. Calculadora, por favor. 84. So angle Z equals 1/2 of the big part. What's the big part on this angle? 84. What's the little part on the angle? 44. Because these don't matter. Okay, you just got to use the parts that the angle covers. So angle Z equals 1/2 of 40. So it equals 20. Okay, now that deals with angles. If the angle's on the inside, we add. The angles on the outside, we subtract. Now, if we're talking about lengths of parts of the chords or secants, if we're on the inside and they cross, this times this equals this times this. Makes a perfect little proportion. Okay? This times this equals this times this. Easy peasy. If it's on the outside, it's the outside times the whole thing equals the outside times the whole thing. That one's a little more complicated. The outside times the whole thing, x times x, equals the outside z times the whole thing, z plus y. Okay, that's for lengths of segments. So this one's pretty easy. This times this equals this times this. So 4 times x equals 5 times 6. 4x equals 30. Divide by 4. X equals 7.5. Bada bing, bada boom, we're done. That's pretty easy. That times that equals that times that. Okay? So how would I figure out y? 15 times 7 equals 10 times y. 15 times 7 is a 5, carry the 3, 105 equals 10y. Divide by 10, divide by 10, y equals 10.5. Easy peasy lemon squeezy. Okay, that's pretty easy. All right. Archaeologists found that part of the circular wall that surrounds an ancient city. They measured the distances shown. The 272-meter segment lies on a line through the center of the circular wall. What's the diameter of the circular wall? Okay, we want to know what x is right here. So when we have it on the outside of the circle, when we have parts on the outside of the circle, we take the outside 272 times the whole thing, 272 plus x. The outside part times the whole thing equals the outside part 310 times the whole thing, 310 plus 805. Outside times the whole thing equals the outside times the whole thing. So if we distribute, we're going to get some big numbers here. Take 272 times 272. Help me out, calculator people. 373,009. Oh. 73,984 plus 272x equals, what's 310 times 310? 96,100 plus 310 times 805. 249,550. Add these two up. 345,650. So then we have to subtract from there 73,984. So 272x equals 200 and what? If we divide by 272, it's really close to 1,000, right? 998.8. Okay. All right. Let's look at this one. The outside times the whole thing. Well, 6 is both the outside and the whole thing. So 6 times 6 equals the outside A times the whole thing, A plus 9. This is where it gets more complicated. 36 equals, what's A times A? A squared plus A times 9 is 9A. This is where we have to do the dreaded factoring. We'll subtract 36 from each side. So A squared plus 9A minus 36 equals 0. And factor, we're second bell. So A and A plus and minus 12 and 3. So A plus 12 equals 0. A minus 3 equals 0. So A equals a negative 12 or a positive 3. Can A be a negative 12 long out here? No, we can't have a negative distance. So it has to be 3. 3 times 12 is 36. 6 times 6 is 36. It makes sense. Okay? What? To find 3. Yep, we did all that to find 3. Okay? So outside times the whole thing, it was outside times the whole thing. So I will just put it on this screen because that gives you all the formulas. We'll stop there. Yes, if you have a